Hello everyone, my name is Jordan Hernandez and today I'll be going over demo for Learning Target 7D. So what is Learning Target 7D about? Learning Target 7D is about I can design logic circuits for data routings. And those data routings are going to be decoders, encoders, multiplexers, demultiplexers, and shifters. But today I'll be showing an example of a multiplexer and how it looks like and how I'm going to design that multiplexer where I basically start and what it shall end to. So first, what I'm going to be starting with is I'm going to be starting with a 2 to 1 multiplexer input output system. And as we can see here, we have our given equation, which is Q is equal to D0 times 3, sorry, not 3, S prime plus D1 times S. So what that would look like in a regular logic circuit display, it's going to have D0, S, and D1 as our inputs, in which we have S going through a prime or a dot gate with D0, and then S going through a regular AND gate with D1. So when we have both of those AND gates being our multiplication, it's then added to our regular OR gate to then get the display of Q. Now for the next thing I'm going to show you is that this multiplexer right here is basically the same multiplexer right here as well. And this one's going to be more as a pre-built, and then this one is just basically the more complex inside version of it. And as we can see here, I0 is basically our D0, our I1's basically our D1, and then our Y is going to be our Q, and our selection is just going to be our selection point right here. And I just kind of have these two arrows just kind of representing that they're basically one or another. You can have this one be represented as your multiplexer, or this one be your multiplexer. But the more preferred version would be this guy right here. For any for our next version, what we're going to have, or our next example, what we're going to have. So our next problem is let's make a 4-bit 2 to 1 multiplexer. And what does it mean being a 4-bit is that it's going to have 4 inputs with 2 values or 2 different values. And for our inputs, we're going to have A0, we're going to have A and B, but they're going to be listed with different types of inputs, or each are going to be 4 bits. So we have our A inputs going to be A0, A1, A2, and A3, while our B inputs are going to be B0, B1, B2, and B3, which our selections are going to be also an input. And our outputs are going to be represented with the different value, which is R0, R1, R2, and R3. So what that'll look like is it'll be looking like this. And as we can see here, this is our multiplexer that we did use previously right here. It's just in a different appearance using Logisim Holy Cross. As we can see, we have A3 going to D0 and then B3 going to D1, which then outputs R3. And as we can see, we start from A3 and B3, and then we end all the way down here to A0 and B0. And it's just kind of the way of the order of most multiplexers. And with our selection, it's going to be down here as our input. Now, what I would like to show you is how a multiplexer basically shows and inputs and outputs. As you can see here, B3 is one input, and then A3 is going to be 0 input. So when we look at this first one at R3, you realize that this outputs only 0. And that's because when selection is 0, it only outputs A values. But when selection is 1, it would be anything of B values. So, and then it works the same way back here. When D0 is going to be 0, or when selection is going to be 0, it's only going to be outputting the 0 values. And then when selection is 1, it's going to be selecting the 1 values down here. And I'll be showing you guys in Logisim. So, as we can see here, as predicted, we have selection being at 0, and D0 being 0, and looks like it only displays 0, so that's one of the things I mentioned. So when selection is 1, it should only output as 1 because it selects only this side of the data, which is D1. So this is my the 2-to-1 multiplexer. So here is the 4-bit one, which is basically the same thing that we did over here. And as we can see, A3 is 1, so, and the selection is 0, so it's going to be displaying A's value. So 1, A2 0, 0, A1's 1, 1, A0, R0, 0. So when we switch it to 1, as we can see here, when B3 0, it displays R3 as 0. A2 0 displays R2, or sorry, wrong way. B2 is 1, so it displays R2 as 1. Then when B1 0, it displays R1 as 0, and B0 is 1, it displays R0 as 1. And that explains how we can basically make a multiplexer using Logisim and digital circuits. I hope you guys all enjoy, and I'll see you guys next time.